Okay, so yeah, let's start the discussion. We were dis- we were discussing about what exactly is the meaning of similarity. Okay, congruency you already know. Similarity we have started, and we were discussing like how to check whether two triangles are similar or not. What are the criteria for similar triangle, and what exactly is the meaning of similarity of two triangles are. Okay, now few more things are there which we need to know, that if we are talking about a circle, I am drawing one of the circle, maybe the radius over here is, maybe the radius over here is 3 centimeters. I am drawing another circle over here. Just a second. And maybe the radius over here is maybe 4.5 centimeters. Now the question is whether these two circles are congruent or not. These two circles are congruent just by looking at the figure. If I will ask you, please tell me, these two circles are congruent or not. Is it congruent? Anyone?
No, ma'am, they're not congruent.
Yes, ma'am. It is not congruent because congruent means exactly same. Shape also, shape is same, circle, circle. And size also, but the size is not same. If the size is not same, we cannot say these two are congruent with each other. It's not congruent. But if I will ask you whether these two circles are similar, so the answer will be yes, these two circles are similar. Because similar means what? It is getting stretched or getting compressed in a certain ratio. So beautifully it is maintaining the ratio which we have seen for triangle. But when we are talking about the circle, here ratio means what? In circle, we only know one measurement, that is radius of the circle. Right? Right? In
Yes.
triangle, three sides are there. Of course, three angles are there. But in circle, only radius is there. Angle, if you will think about angle, here also it is 360, here also it is 360. We are talking about a circle. So angle we don't have to worry about. Okay. So only radius we need to compare, that the radius are in proportion or not. So what does that mean? How we will check the ratios are same or not? 3 is to 4.5. Okay. Here we don't even have to check the ratio. Whatever ratio will be there, it is completely fine. We can say that whatever measurement we will be drawing to circle, since we cannot check this ratio, that ratio, just like a triangle. But in other shapes we can check. If I will draw a rectangle over here and I will draw another rectangle, it looks like a square, but assume it is a rectangle. If then you can check the ratio between one of the side over here to one of the side over there, the ratio between another side over here BC to another side over there, the ratio between another side over here to another side over there. Okay, the ratio between DA to PS, that you can check. Okay, but in circle, which ratio we will be checking, whether all the ratios are same or not. Since we cannot check only radius we are having, for the case of circle, we will say that two circles are always similar. Two circle, whatever be the measurement, are always similar with each other. Two circles are always similar. Are you getting it? It is not congruent, but it is similar. Any confusion? Getting it?
Yes, ma'am.
Yes, ma'am.
Just a second. So we can say that two circles are always similar with each other. However, for other shapes, we have to first check it. All the ratios between the sides are same or not, and internal, these angles are also same or not. However, if I am saying we are comparing rectangle ABCD with rectangle PQRS, then internal angle we don't have to think about, because rectangle I am saying that of course interior angle has to be 90 degrees. Okay. Now one more, there are more figure like this circle which will always be similar. Okay, which figure? So think about it. If we will be having a square and if we'll be having another square, this is ABCD, this is PQRS. Now since I am saying this is a square and this is also a square, so square means suppose this side is 5 centimeter, all the sides will be 5, 5, 5 and 5. Suppose this is a square. If this side is 8 centimeter, all side will be 8, 8, 8, 8. Now can you see ratio will automatically, ratio will be same. Yes or no? Yes or no? Ratio between AD to PQ, or you say PS, whatever side you take. BC to QR, CD to RS, and DA to SP. These all the ratios will be same, right? Right? So whatever measurement you are taking to a square, once you are drawing to a square, it will always be similar, because automatically the ratio will become same. Why? Because square is having the property that all sides are of same length. Since all the sides are of same length, obviously the ratio will come out as the same. Are you getting it? Instead of 5 and 8, even if I can take here 6 centimeter, there 11 centimeter, still the ratio will be same. Instead of 5, any measurement you have, one of the square, another square, whatever be the measurement, it will always be similar. But these two are not congruent. These two are not congruent figure. Getting it? Yes. Are you getting it?
Yes, ma'am.
Here I am writing two squares are always similar. But about congruency, we can't say. We have to check that whether sides are of equal lengths or not. That we have to check. Now, apart from circle and triangle, is there any other shape which we can say that if even if I will draw a teeny tiny figure and one the bigger figure, still it will be similar? Any other shape which will always be similar? Whatever measurement I take, it will be similar always. Any other shape is there? Circle, you know. Square, you know. Any other shape is there? Can we say two equilateral triangle? One
Yes,
triangle
ma'am.
and another triangle. If this is equilateral triangles, this both are equilateral triangles, then again it will maintain the same ratio, right? And what about the internal angle? See, equilateral triangles, internal angle consists of 60 degrees. So internal angle will also be same. Getting it? Similarity का मतलब ही होता है sides are in proportion, that means sides same ratio maintain कर रहा है और angles equal है. Getting it?
Yes, ma'am.
Okay. So yeah, this is how now we can make one more declaration, one more conclusion we can write that two equilateral triangle are always similar. Okay. Now the next one. On the basis of these concepts, you are having fill in the blanks in the first exercise. Check it. Check it. The fill in the blanks we are having like this. All circles are dash. Okay, options are given over here. It may not be given in your exam. Here it is given all circles are congruent or similar. So what will be the correct option from here? Yes,
Winner.
all circles are dash, all squares are dash, all equilateral triangles, all dash triangles are similar. Equilateral will be filling here equilateral. Okay, all squares are also similar. All circles are of course similar. Okay, now only we discuss this. Please tell me the fourth one. I am writing it over here and you are going to tell me what will be the what we are going to fill in the given blank. Two polygons of the same number of sides are similar if their, let's focus on four now. Okay, corresponding angles R dash and B their corresponding sides are dash. Okay, for both the blank options are there, equal or proportional. This may not be given in your exam, but here since it is given, I am writing it. Okay, what shall we fill in the first blank and what will be there in the second blank? Yes, any idea? Afnan, Alvina, Abdul, who else is
Ma'am, first is proportional.
first one will be proportional and next one will be,
Equal.
let's read about it. Two polygons of the same number of sides are similar. Two polygons are similar if their corresponding angles
Angles are equal. Angles are equal and sides are proportional.
exactly angles are equal. Afnan, angles are equal and sides are in proportional. Getting it?
Yes, ma'am.
Okay, angles are not proportional. We compare, proportional means same ratio. Okay, so sides are proportional and angles are equal. That's what the meaning of similarity is. Okay, so yes,
Okay,
we'll
ma'am.
be filling accordingly. Let's move. Now we are done with the first exercise. Now in detail we need to discuss similarity. However, yes, from yesterday we are discussing similarity only. Here we need to discuss basic proportionality theorem also. Okay. So again we will come to this concept of similarity, but now we need to start the discussion of basic proportionality theorem. Okay. This theorem is very, very, very important. Let me write it over here. So the statement says that first you need to understand the statement. Okay. The, then I'll also be showing you the proof. But proof we'll be taking from the next class. Today I'll be explaining what does it mean, and we will solve few questions by using this theorem, so that we can understand at least the theorem first, and then of course we'll be proving it. So the statement says if a line is drawn parallel to one side of a triangle intersect the other two sides in distinct point. The other two sides are divided in the same ratio. Let's read it and let's try understand. If a line, if a line is drawn parallel to one side of a triangle. If a line is drawn parallel to one side of a triangle. So suppose we are having a triangle ABC. If a line is drawn parallel to one of the side, okay, how will be drawing a line which must be parallel to one of the side? It must be parallel to maybe side AB, or maybe side BC, or maybe side C. Okay, intersect the other two side. It must, in the line which you are drawing, it must intersect the other two side. So let's draw a line which is parallel to BC and intersecting AB and AC. A line we have drawn which is parallel to one of the side and intersecting the other two side. Why we have drawn like that? We can draw any other sides parallel line. Yes, we can draw. Okay, this is the possibility number one. Or you can draw a line, same triangle I'm plotting over here, ABC. We need to draw a line which is parallel to one of the side. So let's draw a line parallel to AC. Okay, AC के parallel एक line draw करने हम जा रहे हैं. We are going to draw a line parallel to the side AC. So maybe the line will look like this. Okay, and the line which we are drawing, it must intersect the other two sides. So yeah, it is intersecting. This line which is parallel, which we have drawn, is intersecting the other two sides AB and BC at two different points. Okay, at a point E and at a point F. We have drawn a line which is parallel to one of the side intersecting the other two side. We have drawn a line which is parallel to one of the side intersecting the other two side, or maybe we can draw a line, parallel to the side AB, okay, parallel to the side AB and intersecting the other two side BC and AC. Again, I am calling it at E and F. Getting it? So far, is it clear? If a line,
Yes,
in
ma'am.
it, you are having a triangle. In a triangle, you are drawing a line. The line is parallel to any one of the sides. So these are the three possibility is getting generated. You can draw any one of them. You can draw any one of them. Then what will happen after this one? Then after this one, okay, intersect the other two side at two distinct points. The other, see, after that there is a comma and then the other two sides are divided in the same ratio. The other two side, okay, other two side where the line is intersecting, that side is getting divided in equal ratio. That side AB and BC is getting divided in equal ratio. That means AE by BE is equals to AF by FC. If you are having a triangle, in that triangle, if you are making a line parallel to one of the side and that line is intersecting the another two side, then at that same point the another two side is getting divided in equal ratio. That means AE by BE is equals to AF by FC. We can use the same concept for the possibility number 2. If we have drawn a line EF which is parallel to AC, now this line EF is intersecting the other two sides. Other two sides are AB and BC at two distinct points. That means two different points E and F. Then the two sides, okay, we are talking about AB and BC, is getting divided in equal ratio. That means do we want to say that BE by EA? Do we want to say that BE by EA is equals to BF by FC? Yes, we want to say the same. Or if you want to take from that side, you want to take first AE, then BE, then here also take it in the same manner. CF by B, FB. Getting it? Are you getting it? Everyone
Yes.
getting it?
Yes, ma'am.
Okay, if you are having a triangle and in that triangle if you are drawing a line which is parallel to one of the side and intersecting the other two side, okay, other two side, here other two sides are this one and this one, this two side at E and F, the parallel line is intersecting. Then this other two side, that means the green, these two green sides is getting divided in equal ratio. Okay, equal ratio. That means AE by EC. Either you can take from the this part, this way. You can take AE by EC is equals to, from here also you have to take from BF by FC. Please maintain the parity. Maintain the sequence here and there. Just don't start jumping. If you are taking from here, then here also take this one at first and then this one. Okay. Or you can say that this CE, okay, CE by AE is equals to CF by FB. Getting it? Let's read in one go. If a line is drawn parallel to one side of a triangle, intersecting the other two sides in two distinct points, the other two sides are divided in same ratio. Whatever ratio it is maintaining. It will be the ratio of this side and the ratio between this, whatever way it is getting divided. These two ratios will be same. I am not saying it is touching at midpoint. Think about it. I am not saying it is touching at midpoint. Midpoint theorem you have learned in the previous class. Here I am saying that it is dividing in the same ratio. That means if the line you are drawing and if parallel to one of the side, this two are parallel with each other. Then if it is getting divided in the ratio 2 by 3, here also it will get divided in the ratio 2 by 3. Are you getting my point? Getting it? Yes or no?
Yes, ma'am.
Okay. Now let's solve few questions which will be based on this base. This is called basic proportionality theorem. Okay. Let me take out few questions which we can do now. There are two figures, 1 and 2, where D is parallel to BC. Okay, and for the first one, we have to find EC in one and AD in one. Okay, I'm drawing parallelly. I'm drawing two figures. One by one, we will be focusing on it. So one of the figure is this. At first, I'm just drawing one of the figure. The name is A, B, C. Here we are having D. Here we are having E. This is 1.5. This is 3. This is 1 centimeter. We have to find the other. Okay. Here it is clearly given that DE is parallel to BC. Now we know that if we are having a triangle where there is a line parallel to one of the side, okay, and intersecting the other two side or touching the other two side, okay, then the other two side is getting divided in the same ratio by basic proportionality theorem we given by Thales, okay, given by mathematician Thales. So sometimes we also call it Thales theorem. In your exam, it can be written as a basic proportionality theorem or Thales theorem. That means we are talking about the same theorem. Okay. Now we know that the side AD by BD, this ratio will be same by BPT theorem. In short, we also call it BPT theorem. Okay, BPT theorem, which means just basic proportionality theorem. Okay, so AD by BD must be equals to AE by EC by BPT theorem or by basic proportionality theorem. Don't write the short form. But in case short form is given, you know that. Okay. So Thales theorem or basic proportionality theorem. Now from here, can you find this? Can you tell me AC, I'm telling. EC. Can you tell me what is EC? Because that's what is asked in the first part. That find EC. I'm waiting for your response. Please find EC. Yes. What are you getting as a EC? AD is 1.5. BD is 3. AE is 1. And what is AC? Yes. Alvina, Afnan. Shall I show it to you how to solve it?
Yes, ma'am.
The EC is in the denominator. We need to bring it in the numerator. Okay. We need to bring it in the numerator. If anyway, you will be having 1 by x is equals to maybe 20, maybe 30, maybe 20 by 7. Then first you need to bring this x in the numerator. Then only you will be able to solve it for x back. Okay. What you can do for this example, you can take this x and you can just shift it to another side. It will go to another side and will get multiplied with 20. Now this way we are taking it to the numerator. Now we can think about finding x value. Okay. This 7 also, the denominator will go to other side and will get multiplied with 1. It will be just 7. Okay. And x will be now 7 by 20. 7 by 20 is the answer. For this example, for our question, first we need to bring this EC in the numerators part. It is sitting in the denominator. So let's take it to that side. Here it is in division, that side it will be in multiplication. Okay, this 3 will go to other side and will get multiplied with 1. EC will be just 3 by 1.5. Are we going to leave our answer like this? No, not at all. Okay, we need to simplify it. Whenever you are having a whole number in the numerator and a decimal in the denominator, or maybe a whole number in the denominator, decimal in the numerator, you need to check here the multiplication of 10 is required to remove the decimal. Okay, and since we are dealing with a fractional term, we are bound to multiply the same 10 in the numerator also. And hence our numerator became 31, 0 is reflecting over here, and denominator decimal just got removed due to that 10. And we are having 15, 2 times 30, EC as a 2 centimeter. Are you getting it?
Yes, ma'am.
तो बेसिक प्रोपोर्शनैलिटी थ्योरम बोलता है कि अगर एक लाइन ऐसा हो हमारे ट्रायंगल में जो एक साइड के पैरेलल, देन हम खुद से लिख सकते हैं कि AD by BU is equals to AE by EC like that. जो साइड के पैरेलल होगा, जो दो रिमेनिंग साइड्स होंगे, उससे वो लाइन सेम रेशियो में डिवाइड करें. अगर एक लाइन पैरेलल है किसी साइड के, तो ही हम ये लिख सकते हैं खुद से. अगर पैरेलल है या नहीं है हमें नहीं पता, तो फिर ये सब we will not be thinking about it. Getting it? If
Yes,
if
ma'am.
if it is parallel, if parallel, then only we can write the ratios are same. Okay, so this is BPT theorem, this is basic proportionality theorem, this is Thales theorem. Now let's take the next figure. You got the idea how to solve it. I'm drawing the next one. A, B, C. Here also the same instruction is there. D is parallel to BC. This D is parallel to BC. Don't worry about this big line or a small line. Okay, we just need to see whether it is touching the another two sides, whether it is intersecting the another two sides, or it is parallel or not. That much only we need to check. And the same concept we'll be using over. Please use it and find AD. We need to find AD over the length of AD. Do it. Yes, what is AD? Shall I solve it? By basic proportionality theorem, we can say that since DE is parallel to BC, therefore we can say that AD by BD is equals to AE by EC. Okay, what is AD? We don't know. What is BD? 7.2. What is AE? 1.8. And what is EC? 5.4. Now we need to find AD. Okay, let's find it. This 7.2 will go to another side. Will get multiplied with this 1.8, and in denominator 5.4 we are having. Let's do the multiplication of two decimal number. Or now only we can try doing the simplification. We can try removing the decimal. Okay, so this number requires the multiplication of 10 to remove the decimal. This number requires the multiplication of 10 to remove the decimal, and this number requires the multiplication of 10 to remove the decimal. So in numerator, are we going to multiply with 10 into 10? 2 times 10. And in denominator, are we going to multiply with only 110? No, fraction will not accept that, because at first the fraction says that whatever you are multiplying or dividing in the numerators part, do the same in the denominator. Okay, that means in numerator, if you are multiplying with 10 into 10, that means 100. In denominator also, we are bound to multiply with 100. Whenever we are having this type of scenario where in numerator you are having this type of number 3.28, and in denominator we are having just 1.2. Okay, numerator requires the multiplication of 100, denominator requires the multiplication of 10, but fraction rule says that be careful. Whatever you are multiplying in the numerators, you have to do the same in the denominator, or whatever you are multiplying in the denominator, you have to do the same in the numerator. Basically, numerator denominator multiply the same number. Now you decide 100 or 10. So we will be saying, okay, 100 we will be multiplying, because in between this 200 is the bigger number. So 100 we will be multiplying, so that in numerator the decimal will get removed, and in denominator one extra zero will come due to the multiplication of 100. One extra zero is acceptable, but we don't want any decimal and all. Getting it?
Yes, ma'am.
Okay, so whenever you encounter such scenario where you have to decide, please take the larger number, because extra zeros are okay, but not decimal. Okay, so same thing we'll be doing here. Numerator requires the multiplication of 100